Hello kids. We have seen two types of reaction. We saw combination reaction and we have also seen decomposition reaction. Now the next reaction is displacement reaction. Now what is a displacement reaction? A reaction in which a more active element displaces the lesser active element from its compound. Like, take for example, the activity that is given in the book. You take copper sulfate solution. This is copper sulfate. And let's say you dip an iron nail in it. We know copper sulfate solution is blue in color. Now when you dip iron nail, iron is Fe, in copper sulfate solution and you leave it for some time, few minutes, what you observe? Iron being more active than copper. Both copper and iron are metal. But iron is an active metal than copper. So what iron does? Iron displaces copper from this compound. So it will form ferrous sulfate and copper. Now because of this formation of ferrous sulfate, what we notice? The blue color of the solution fades because of formation of ferrous sulfate. The blue color was due to copper sulfate. Moreover, what you will notice, the iron nail turns brown. Now why does the iron nail turns brown? Because during this reaction, this copper which is obtained gets deposited on the iron nail. And we know copper is brownish in color. Now when the copper gets deposited on the iron nail will turn brown. So this was your displacement reaction. Let's look at few more examples of displacement reaction. The reaction of zinc with copper sulfate. A similar example. Zinc being more active than copper. So what zinc does is zinc displaces copper from copper sulfate. So this also is an example of your displacement reaction. Similar example of lead with CuCl2, copper chloride. Lead being more active, lead displaces copper from its compound. So all these are examples of displacement reaction. So what happens in a displacement reaction? The more active element displaces the lesser active element from its compound. Now the next type of reaction after displacement reaction, it is double displacement reaction. Double displacement reaction. Now what is a double displacement reaction? So we say reactions in which there is an exchange of ions. Those reactions in which there is an exchange of ions between the reactants. Those reactions in which there is an exchange of ion between the reactants are called double displacement reaction. So there is an activity to explain double displacement reaction. Take two compounds, one sodium sulfate in one solution in one test tube, and in the second test tube take barium chloride. So we know sodium sulfate is formed by sodium ion and sulfate ion, and barium chloride is formed by barium ion and chloride ion. So when you mix the content of both the test tube, sodium sulfate and barium chloride react with each other and there is an exchange of ion. These two ions combine and these two ions combine. So you get NaCl and barium sulfate. This barium sulfate is water insoluble, hence it is obtained in solid state. Here this was in aqueous state, this is in aqueous state, and sodium chloride is also in aqueous state. Now barium sulfate obtained in solid state is a precipitate. Hence this reaction is an example of precipitation reaction. So that was double displacement reaction. The next type of reaction is your oxidation and reduction reaction. Oxidation and reduction. What is oxidation? Oxidation is addition of oxygen, or it is removal of hydrogen. The opposite of oxidation is reduction. So what will be reduction? Reduction is addition of hydrogen or removal of oxygen. Whenever in a reaction the substance from which oxygen is removed or hydrogen is added, we say that very substance is reduced. Similarly, the substance in which oxygen is added or hydrogen is removed, we say that substance is oxidized. In textbook, there is an activity to explain this. What are we doing in the activity? In the activity, we take a china dish. In the china dish, we take copper. We know copper is brown in color. We heat this copper on a burner. When you heat the copper reacts with oxygen of the atmosphere. The copper reacts with oxygen of the atmosphere and it forms copper oxide. We know copper is brown in color and copper oxide is black in color. So what we notice? The brown color copper on heating changes to black color copper oxide. Now here oxygen was added in copper. So we say copper got oxidized to copper oxide. Now when you pass hydrogen gas through this hot copper oxide, which is black in color, what we notice? Hydrogen displaces the copper and forms H2O and you get back the copper. So now the black color of copper oxide again changes to brown color of copper. Now what happens in this reaction? In this reaction, copper oxide is losing oxygen. Now because copper oxide is losing oxygen, we say copper oxide got reduced to copper. Here copper got oxidized to copper oxide because oxygen was added in copper. Here copper oxide is getting reduced to copper. Why? Because copper oxide is losing oxygen. Yes? So that is one example. This activity is important. It is asked many a times in the exams. Now, to take a few more examples, like they have given in the textbook, the reaction of zinc oxide plus carbon. We use this reaction in the metallurgical industry. What happens? The carbon displaces this oxygen and the oxygen gets combined with carbon and it forms zinc plus carbon monoxide. In this reaction, zinc oxide is losing oxygen. So we say, because zinc oxide loses oxygen, we say zinc oxide got reduced to zinc, and carbon gains oxygen, so we say carbon got oxidized to carbon monoxide. One more example in the textbook is the reaction between manganese dioxide MnO2 and hydrochloric acid. They react to form manganese chloride H2O and chlorine. So what do we notice? We notice that manganese dioxide loses its oxygen and it forms MnCl2. Now because it is losing oxygen, this is your reduction reaction. So we can say manganese dioxide gets reduced to MnCl2. Then what else do we notice? We notice that hydrochloric acid HCl is losing hydrogen and it forms Cl2. Now because HCl loses hydrogen, we say this is your oxidation reaction. That is HCl gets oxidized to Cl2. So these were few examples of your oxidation and reduction reaction. Now because oxidation and reduction, we notice they are occurring simultaneously, so they are together, they are called as redox reaction, which is reduction and oxidation. Yes, so that was your type of reaction. Now the last topic is corrosion and rancidity. So first let's take corrosion. Corrosion is not at all a new topic for you. We know that metals react with oxygen of the atmosphere in presence of moisture, and the metal gets tarnished. Metals are shiny substances. They lose their shine, that is, they get tarnished when they react with oxygen of the atmosphere in presence of moisture. They form a layer of oxide on their surface. This process, where a metal gets tarnished by reacting with oxygen of the atmosphere in presence of moisture, is called as corrosion. We know iron, when it reacts with oxygen of the atmosphere in presence of moisture, it forms Fe2O3.xH2O. This is corrosion. Corrosion of iron is called as rusting, and this is the formula of rust. Similarly, aluminium, when it gets corroded, it reacts with oxygen of the atmosphere and it forms aluminium oxide. Silver, when it gets corroded, it turns black. Silver in presence of H2S, it gets corroded and silver turns black. Copper, when it gets corroded, it turns green. Copper reacts with the moisture of the atmosphere and the carbon dioxide of atmosphere, and it gets corroded and it turns green. So this is corrosion. Is corrosion a desirable thing? So no, corrosion is not desirable. Why? Because corrosion eats away the metal. So what do we do to prevent corrosion? We oil the metal, we paint the metal, we do a coating of paint so that the metal beneath the paint remains protected from the atmosphere. We also do a process called as galvanization. What is galvanization? In galvanization, we coat the surface of iron substances made from iron with zinc to prevent the corrosion of iron. This process is called as galvanization. Yes. The next topic is rancidity. What is rancidity? When fats and oils get oxidized, they develop a bad smell and taste. They turn stale. This oxidation of fats and oil is called as rancidity. Now, to prevent rancidity of fat and oil, we use substances which slow down the rate of their oxidation. Such substances which are used to slow down the rate of oxidation are called as antioxidants. We also take a different approach to prevent oxidation of fats and oil. We store them in airtight container so that we prevent the direct contact of fats and oil with oxygen. Other approach could be you can refrigerate them at low temperature. The speed at which the fats and oil will get oxidized will retard, hence you could prolong the shelf life of fats and oil. Again, you can store them in cool places. You could also flush the container with some inert gases like nitrogen. For example, chip manufacturers. Chip manufacturers, when they make chips, the edible chip, the one that we eat, they flush the packing with nitrogen so that there is no oxygen in the packet, and nitrogen being inert does not react, so it again prevents the oxidation of such fats and oil. So that completes the chapter. Thank you.